Hello, hello, hello. So we're back. We're back with part 4 of our house design from start to finish series. And in this video, I'm going to kind of continue on where we left off. So just as a refresher, this is the house that we are designing and that we are going to build. And it's a pretty simple concept, one-story building, a residential building for a private client. And we've just finished our construction documentation stage, right? So we have all documents necessary to send them into the municipality to get a building permit. So basically to apply for a building permit, what am I saying? So in this video, I'm going to show you what we actually have and what we actually are going to send. Right here, we will start with additional documentation from a beautiful company with a beautiful name, Sons of Drilling. And so this is geological geological analysis of the site, and most of it is kind of boring and just, location and text. I shouldn't show that. But the interesting thing that I find to be quite cool is the section. So here you have, basically they make a bunch of holes in the ground, right? And they take out these samples of different levels or layers, and in doing so they can create a cross section of the site, and they can exactly know what kind of a soil we are dealing with, right? So what kind of foundation we will need. So here you can kind of see a little diagram showing how they drilled and how deep they went, right? From 165 meters above sea level to 158.5, right? And what's more important is what kind of soil they found. So I will not go into soil because I would need to translate that, but instead I will just talk about density. So VT is, you probably can't see it. Let's zoom into this bad boy. VT is average density and T is high density, high density, right? So with these measurements, we can see which parts of the soil have high density and which have low density, which helps the engineer later on, the construction engineer later on, to determine what kind of poles or what kind of foundations, we will need, what type. So that's it about this part, right? Next up, we have construction. So this comes from the engineer, and we hire an external engineer to do this for us. And basically the documentation is kind of the same thing as what we have with geology. Most of it is boring, right? So I'm going to skip ahead and just try to find parts that are a little bit more, at least visually interesting. But just the gist of it is engineering takes care of everything that has to do with building tectonics and building, actually standing up, right? So loads, transferring of loads, and so on. And usually together with engineer, we discuss and we go back and forth and we change the design according to what kind of a structure is more efficient or more logical to do, unless the structure itself completely destroys the architectural intent. Then then we just go for a more expensive structure. So here I can't really see anything that's there we go. What kind of armature you will have in the foundation. I guess these are the foundation poles. Yes, they seem to be, at least, like also where the poles should be placed. is going to be shown here in this plan. So that's engineer's part. Then we have the bottom perimeter of the house and armature of it. How you should... Is the word arm it? I don't know. But basically the distribution of the armature in it. Then we have the walls and how you should build up the walls. And also a bunch of details. A bunch of details showing, you know, different like critical moments in the design. And how it should be solved. Also the roof plan with all of the slabs here. So as I'm showing you this, like I guess two-dimensional part is not that interesting. So I will show you instead what the engineer sends us as well. Sends us in 3D, sorry. So this is the model from, I don't know what kind of software they use, but it does import into Rhino quite well. And here you can see that we have wood, concrete, column armature, perimeter armature, concrete slabs, expansion joints, and I-beams, these layers, sorry. So if I hide, let's hide all of them and just open them up one by one, right? So I'll start with I-beams, bam. So this is, these are all I-beams that we will have in the 3D model. And as you can see, they're modeled out pretty precisely, which is nice. Then we have expansion joints. I guess I should show you expansion joints together with the concrete slabs. So concrete slab, expansion joint, concrete slab, expansion joint, and so on. Of course, I renamed the layers for the video. We get it a little bit differently, but let's just say we get it as cleanly as you see here in the video. So that's that, right? Also, what the hell is this? Probably mislayered it. Then we have perimeter armature. So that armature that you saw in the 2D drawing is the same thing here in the 3D model, which is very nice to have. And we really appreciate the engineer taking care of this in 3D, not just in 2D. Column armature. Same thing. And then one column for some reason. Don't worry about that. Concrete. Everything that is concrete. You know, like these are technically not concrete. These are blocks, but close enough. Right? And then wood as the last part. So wood cladding. This is not wood. Don't worry about it. This should be concrete. God damn it. I'm mislayering everything, but you get the idea, at least, right? At least we know for sure that this is wood, and also the whole top is formed as if it was, not as if, but it is formed as a roof, as a wood construction. So this angle right here that you see with these wooden beams, you should be able to see it right here. Like this is the same facade. This and this. Okay, so that's what we get from the engineer. And again, we go back and forth and we talk it through, and we discuss, you know, certain changes that need to be made to the design so that it actually works. For instance, this column right here, right? Everyone likes corner windows without any columns, but in this case, just makes sense to, you know, actually support this point right here. So we added a column. But that's basically it. The 3D model doesn't get uploaded together with the rest of the documents to get the building permit, but it's a nice visual aid for sure. So with that in mind, these two documents, having these two documents, we kind of change the design. We do the final pass at the design, making sure that everything is correct. Everything, you know, that we've done is fine. And we do the last kind of documentation part right here, right? So this documentation is going to be kind of bundled together with those previously shown 2 PDFs. Next up, you think I'm done? I'm not even I haven't even begun. The next beautiful document that we have is building energy efficiency calculation. And we actually have 2 versions of it. And those are both calculated by external, not contractors, but I guess engineers, external engineers, right? So it's calculated according to both the construction documentation from engineer side and from the architect side, right? So we send the documents in, and then the building efficiency gets calculated, right? So 2 versions to it. This is the short version, 1 page, just talking about different numbers, basically. Example. How many kilowatt hours for square meters in a year will this building need to be heated up, right? So 12.11. In a year, how many kilowatt hours will this building need to be cooled down? 6.31, and so on, right? So we get these numbers, right? Like how much electricity is gonna eat, and so on, and then we get the class, right? So this is the short version. The long version is 30 pages long. And honestly, the only thing that matters is this little thing right here. Highest energy efficiency class, A++. If we don't get this, then the building permit is out of reach. There's no way that we're gonna get a building permit if we don't have A++, since I think since January of 2021. So for a year now. So that's fun, but we did get the A++, so that's a go ahead, right? So we are done with the building, but we're not done with the site. There is one more thing that needs to be done, and that is water drainage, water collection from the roof. I guess not one thing then. Geothermal heating, because this building will have geothermal heating. And what else? I guess that's it. Drainage, water collection, and geothermal heating, right? So that part is also done not by us, but by engineers, right? And in their field. And they give us this kind of a document, like 41 pages, blah, 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 a bunch of stuff. Really not going to show you that, but this is the most important part that we have, this diagram. And then we take this diagram and also, some information from the text, we do read it, and we bring it back into our documentation, right? So now the site has been updated with additional things, right? And in here, I'm just trying to find like a proper, for instance, the pink one is the geothermal heating network, right? That's going to be underground. So all of the pink coordinates are for that. The green ones are for rainwater collection, I believe, and so on, right? I'm not going to go too deep into this, but basically we take that information and add it to our portion of the project. So by the end of it, we have 80 pages with 200 pages of supplementary material, but the main part is 80 pages. And this part is indeed prepared by the architect, not by engineers or anything like that, right? So architect basically works as an intermediary between all engineers and all professionals in their fields, right? And just condenses everything into one document. And this document is going to be sent to the municipality to get the building approval, right? And that takes, let's say, takes some time, and we will get a few probably we will get a few notes, a few things that we will need to change, but hopefully not. We'll see. So I'll go through this document real quickly, just to show you what's in there, right? And I'll skip through the boring parts because I don't think you need to see the boring parts, but let's go through it. This is just basically explanation of what the project is about and what you have. This is like the energy efficiency part of it. This is the fire safety part. Here we have like a second degree of heat tolerance or fire tolerance in a building. That's nice. Like most of this text, I'm just skipping through it. We're at page 29 and I almost haven't talked. Most of this text is just copy paste between most of residential buildings, so it's kind of boring. This might be interesting. This is how much of electricity draw can the building have. This is what was established by the energy department. I don't know, Department of Energy. So it's class 3 and 28 kilowatts, if that says anything. So at page 47 we start seeing what you've already seen in this video, like drawings of the site with different kind of layers of information in each drawing, the foundation plan, then everything that's related to heat, right? For the roof, for the walls, for the doors, and so on. And here you can see actually this is a pretty interesting graph. In the bottom you can see what's the norm to receive different classes of energy efficiency for the heating, right? In terms of heating. So if you use 136 kilowatt hours per square meter throughout the year, then you'll get energy efficiency class B. For A++, you need to use 60.99, so almost 61 kilowatt hours per year. So more than twice less energy. In our case, we're going to be using 12.11, right? So it's a highly efficient building in terms of heat, which is nice. And we even have like diagrams showing the cold bridges and calculation of cold bridges in the building. So as you can probably see, very important, heat and energy efficiency, very important in Lithuania. That's what you do. Anyway, enough about this. So what's next? What's in plan? We will upload this to the municipality. We will get the building permit one way or the other. We will get it. No, I shouldn't say one way or the other. That implies some shady business. No shady business. We will eventually get it. And then we will start building. I don't think I will make any more videos about the documentation part because, oh my god, one video is more than enough about it. I will resume the videos once we actually begin construction. And those videos are going to be a little bit different because I'm going to be going with a camera to the site and actually filming it, which should be fun. But I don't think that's going to happen anytime soon. But you never know. It might. Okay. Thank you for sitting through this with me. I hope you learned something, got a little bit of an insight, and I'll see you in the next part. Probably late spring. See ya.